For our first identity, the first step I came up with was to change everything into sine and cosine and use Pythagorean identities. So tan squared x will be changed into sine squared x over cosine squared x, and then sine squared x, all of the sine squared x's will be changed into 1 minus cosine squared x, or cosine squared x's will be changed into 1 minus sine squared x's. I recommend only changing the sine squared x's because then you will be left with the cosines in the equation. And this step would involve only changing the left side. The second step I came up with was changing everything on the left side into cosine using power reducing identities. So sine squared x will be changed into 1 minus cosine 2 theta over 2, and tan squared x will be changed into 1 minus cosine 2 theta over 1 plus cosine 2 theta. The second identity would involve changing everything into sine and cosine. This would change the right side of the equation, and tan x will be changed into sine x over cosine x. Step 2 would be using a double angle identity, and that would involve changing the sine 2x on the right side of the equation into 2 sine x and cosine x. So for the final identity, this would involve using a difference identity. So tan x minus pi over 4 would be changed into tan of x minus tan pi over 4, all over 1 plus tan x tan pi over 4. This would only involve changing the left side equation and not touching the right side of the equation. And step number 2 would be changing all of the tans into sine and cosines. I don't recommend doing this because this would make the equation very messy, as you can see below, and you should only change one side at a time, and if you were to do this step, I would recommend only changing the left side.